Hello guys, my name is Desmond and I welcome you to my lesson for today where I'll be looking at analytical geometry. So guys, please make sure that you've got your mics muted so that we don't get disturbed by the background noise. I hope everyone is doing well on your side. So just a last confirmation, did you all say everything is clear? Are you guys able to see and can you clearly hear me when I speak?
Yes, sir.
Yes, sir.
Okay, 100%. Ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important, good people, because what I'm about to say, it's massively, 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 hey, massively important that I say a day without learning something new, it's a day wasted. By so saying, good people, please make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So in today's lesson, we'll be looking at analytical geometry, as I've said. So this chapter, you'll find it there in grade 10, 11, and 12. So, good people, when we are looking at analytical geometry, there are three main things that you need to be aware of. So I'm going to take you through what we call the distance formula. The distance formula, you should know the midpoint formula, you should know, and most importantly, the gradient formula you should know. So this is part of a grade 10 revision. Then as soon as I've introduced you to these three types of formulas, we will go deeper into what you should expect in grade 11 and 12. So guys, you should know these formulas by heart. Let's say number one, the distance formula. We do know very well that the distance formula, it is actually equals to the square root of x2 minus x1 close squared plus y2 minus y1 close squared. I want you guys to notice something from these three formulas. Let me also talk about the midpoint formula. So the midpoint formula, it has an x and y value. Let's say the midpoint formula for the x value, it doesn't matter whether you say x midpoint or whatever, whichever way you represent it, as long as it can be represented correctly. So let's say the midpoint for the x value is going to be x1 plus x2 over 2. And also you will need the midpoint for the y value being equals to y1 plus y2 divided by 2 over there. The gradient formula, ladies and gentlemen, you can just say G representing the gradient. So gradient slope is one and the same thing. The formula is the same. It is change in y over change in x. Remember guys, this sign, it is actually a Greek sign. So it is called change. It is called delta. So delta is the Greek word. In our English word, it simply means change. So we have change in y over a change in x. What does change mean, ladies and gentlemen? Change simply means y2 minus y1 over x2 minus 1. So can you see? It's change of y. So the moment you say change, it's more like you're saying final minus initial. But in this case, because we're dealing with analytical geometry, we refer to that as y2 minus y1. So it is as easy as that. Something very much important that I want you guys to notice over there. Number 1, number 2, number 3. There's something common, or let me say, something which is almost the same, is the fact that for you to calculate either the distance, the midpoint, or otherwise the gradient, you always need 2 points. Very, very much important, ladies and gentlemen, over there. What are the 2 points? So that means you will need x1 and again its corresponding y1, and also x2 and its corresponding y2. These are the 2 points that I'm talking about. So you can see x1, x2, y1, y2, x1, x2, y1, y2, there, y2, y1, x2, x1. So that means, ladies and gentlemen, for you to get ready for this chapter, you need to be aware of this formula. So I'll just give an example, and then from there, we'll try to derive some questions based, ladies and gentlemen, based on these 3 formulas. Let's say, for example, we've got a Cartesian plane. I see we've got Notolo there. I think Notolo, she's attending my lesson for the very first time. Notolo, I've always been saying there's something that we call a Cartesian plane. What is a Cartesian plane, ladies and gentlemen? A Cartesian plane is just a vertical straight line called the y-axis, and again having the horizontal line called the x-axis. And most importantly, guys, a Cartesian plane has got this point of intersection that we call the origin. So this is the starting point of all the positive y values, the positive x values, the negative y values, the negative x value. So that point, it is called the origin, and the value there, it is 0. Remember, guys, a Cartesian plane has got 4 quadrants. This one being the first quadrant, second quadrant, third quadrant, fourth quadrant. What do we use a Cartesian plane for? So a Cartesian plane, ladies and gentlemen, is like a plate that you use to eat. So we use a plate, ladies and gentlemen, to put food in the plate. So you'll be having your mountain-like pap over there. I know Jasmine eats too much, so she'll be having too much pap there, which looks like a table mountain. And she'll be having some nice gravy there. What else? I think Jasmine, she likes eating pap with mayonnaise, so she'll be having some mayonnaise there. What else is here going to be? Some peanuts over. Ladies and gentlemen, what am I saying over there? I'm simply trying to say the plate is more like a Cartesian plane. Then inside the plate, we put the food. The food, which could be the graph of g of x, which could be the graph of f of x, which could be the function of h of x, which could be any other function, ladies and gentlemen. So just make sure that you don't confuse the two, because I know, especially you guys in grade 10, when you're seeing functions for the first time, yay, you go crazy. But don't worry that much, ladies and gentlemen. Just know that we draw functions on a Cartesian plane. So this is a plate where we are going to put in everything on the plate so that we can have a nice meal. Okay, so now let's dish our pap now. So this is our pap. It's just a straight line from there up to there. So this is the end, or let me say this is the start and this is the end. To make things easy, let's call this point point A, ladies and gentlemen, and also call this point point B. Remember, guys, I've always been saying we have a letter, then we've got the coordinates. So this letter is what we call a point. So it could be any letter from A up to Z. But can you see, I chose letter A for Analdi there. So that means Analdi is standing there, and we've got Byron standing over there. So what are the coordinates of Analdi there? So the coordinates of Analdi, ladies and gentlemen, remember the coordinates are in a format of x and y. So that means in the second quadrant, we know we've got negative x values. Let's just assume the negative x value to be -3, positive to be, let's say, +2. And then on the first quadrant, we know we've got positive values. So let's just assume the points there to be what is it, 2 and 2. Maybe let's say we've got that line again, ladies and gentlemen. So this one, it is going to be our masonja there. So let's say maybe this point is point C over there. So remember, guys, this is a plate. So we are now dishing our dinner there. So we've got our pap, and then now we are hammering masonja there. So obviously, we are going to have a negative x value and negative y value, because this point, it lies in the third quadrant. And there, ladies and gentlemen, let's refer to that as point Desmond. Therefore, the coordinates over there, let me see, realistically, maybe let's say this is point 3, and then that one could be point 1. Remember, nothing is drawn to scale over there. When we say nothing is drawn to scale, or something is not drawn to scale, we're simply saying don't try and take a ruler to say, hey, this distance from there to there, okay, we can see it's 2, but from there to there, it actually seems to be 4, because it seems to be twice that distance. So don't use a ruler to try and check if this thing is accurate. That's why we say it is not drawn to scale. Okay, so let's see. Maybe let me add, so we've got pap, we've got masonja, but we need, what do we need over there? Archer. Okay, let's add something to our meal. So let's say maybe this is now point E. Obviously, point E might not be given the coordinates, but you do know very well that what are the coordinates at that point. So ladies and gentlemen, these letters, they therefore represent the points, and these are what we call the coordinates. Okay, so now let's try to do a bit of a revision. We won't be performing any calculations, but we'll just have a discussion over there, ladies and gentlemen. Okay, so let's see. The first question, I would say, calculate or determine the distance of AB and the midpoint of AB. So remember, guys, with me, it's not just a matter of performing the calculations, but we firstly have to discuss exactly how to tackle questions similar to that. So ladies and gentlemen, when they say determine the distance of 2 points, in this case, I'm saying determine the distance of AB and midpoint of AB. This is what you should ask yourself. Whatever that they want me to determine, whether being the distance, midpoint, or gradient, do I have the coordinates of the 2 points? If an answer to that question is a big yes, then it means you can therefore go and choose the relevant formula. So the first question I said calculate the distance, which means you're going to use that formula, the first formula. So here comes a question, guys. Sometimes you're not sure in terms of which one is x2 and which one is x1. So I've always been explaining during term 1 and term 2 to say numerically, 1 comes first, 2 comes second. Alphabetically, or alphabetically, you first have A, then B. So can you see? You can just use your logic to say the letter that comes second, it will be my second values, which means B, it is going to be your x2, and then A, it is going to be your x1. In terms of Y, B is your second values, and then A is your first values. Similarly, if you had to deal with C and D, which letter comes first? C comes first. So that means this is x1, y1, and this one comes second. It is going to be, what is it? x2, y2. Easy, 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 easy over there, ladies and gentlemen. Okay, so now let's try to check some. Let's try to check some. Let's try to check some. Okay, so now that they want you to calculate or determine the distance between A, or the distance of A and B. So in short, they are simply saying from there all the way up to there, what is the length or what is the distance? Which means the length and distance is one and the same thing. Is just to know from here to there, how long will it take? So in real life, it's more like they would say, how long is it from Joburg to Pretoria? Then, if you know the coordinates of the center of Pretoria and the center of Joburg, you can easily calculate the distance that you would travel straight from the center of Pretoria to the center of Joburg. We still use the same formulas at workplaces, ladies and gentlemen. So that is why it is best that you understand this formula, so that when you study pilot, when you do this thing, what is it, aviation, you are able to perform calculations to know what is the distance from OR Tambo to Mexico. So in that way, ladies and gentlemen, you are able to also use trigonometry to calculate some angles, which will give you the direction to say, if this is OR Tambo, if this is the airport, and I want to go to Cameroon, if my pilot is facing, my aeroplane is facing in that direction, you make use of trigonometry to calculate the angle, so that you know that you just go straight in that direction and use this formula to know how long do you have to travel to get to Mexico. But for some of you guys who don't attend our math lessons, I'm telling you, you will get to aviation school, and when you get there, they will say, take us to Zimbabwe. I'm telling you, you are going to head straight to Malawi. Why? Because you do not attend the lessons. You therefore don't know what is the trig ratio of sine, tan, or cos. But just make sure, ladies and gentlemen, that you don't miss any of our lessons and you fully understand what we are teaching over there. Okay, so the midpoint formula. In terms of the midpoint formula, easy, easy, easy. Ask yourself, between which 2 points? Between A and B. Okay, do I have the coordinates of A and B? There you go. Easy, easy, easy. You just substitute already. You do know very well in terms of which one is your x2, which one is your y, 1, x1, x2, and so forth and so on. So the gradient of CD and the distance of CD is what they would say determine. Okay, ask yourself this question. If they want the gradient, do I have the 2 points or the 2 coordinates. Let's check. We're talking about CD. There's C, there's D. So, ladies and gentlemen, when they say the midpoint, first ask yourself this question: do I have the coordinates of those 2 points? If the answer is a big yes, then you can easily if it's a no, then it means you must make means to find the second point in order to substitute into the formula, because the formula wants you to have 2 coordinates. Very, very much important, ladies and gentlemen, over there. Now, let's see the midpoint of EF and the gradient of EF. Where is E? There is E. Where is F? There is F. Okay, here comes a question. Because they want me to determine the midpoint, do I have the 2 points and the coordinates of the 2 points? Can you see? This is point E there, but it is not given the coordinates. But because you know that point, it is the origin. And at the origin, that's where you have your x being 0 and your y being 0. Make sure that you write it there so that you can say, yes, I've got 2 coordinates. Therefore, you can easily substitute into your formula. And most important, ladies and gentlemen, which is something that most of you do, you forget to substitute inside the brackets. Ladies and gentlemen, especially there, we are seeing movies there when we mark your scripts, guys. Also there, we are seeing movies there, ladies. Some of you guys are showing us Jackie China there in your calculations, and we just laugh. There's nothing we can do, guys. We just give you a big 0 and laugh. Sometimes we get tired of laughing. We just collapse, guys. Just make sure, ladies and gentlemen, that at all times, when you substitute, you put inside the brackets, whether it's a positive or it's a negative value. It puts you on a better position to get correct calculations. So, especially when you have a negative value, make sure to substitute inside the brackets. If it's a positive value, I would understand, but for a negative value, make sure okay. So now, as I've explained, the distance, it tells us the length from that point to that point. And then now the midpoint, ladies and gentlemen, this weight, midpoint in full, is actually middle. It is actually middle. So it's more like we want to know the point in the middle of the 2 points. So when we say the midpoint of A and B, then you can just make an assumption that possibly it could be that point over there. So already you know what to expect. You are expecting, if it's along there, you can see you're expecting 0, and then the y value, you might be expecting still that same value or whatever that you get when you calculate. So let's say maybe you're expecting a positive y value still, because the middle point, it is above the origin there. Also, the midpoint of that line, you can just somehow say it is somewhere maybe there in between. That is the point in the middle of the 2 points. So you already have an expectation to say your x value, you're expecting a positive value, but your y value, you're expecting a negative y value. Similarly, there, the middle point, that is the midpoint of that line, you are expecting a positive x value, and again you're still expecting a negative y value over there. So what I now want to talk about, ladies and gentlemen, is the gradient. Remember, guys, it is very much important that you are able to visualize these things, because it helps you to gain confidence when you perform some calculation. Okay, this is a Cartesian plane. Now you know very well what is a Cartesian plane. Vertical and horizontal, x-axis, y-axis, that point being the origin. Okay, so now if you have, ladies and gentlemen, this line, a straight line similar to that, and we ask ourselves, what is the gradient there? So it's more like we are asking, is this line flat or is it sloping? you can see this line is flat, ladies and gentlemen. If it's flat, then it means the gradient is equals to 0. Let me not use M over there and use Bra George. So Bra George being G for the gradient. So the gradient is 0. Why is it 0? Because this is flat. So that means having a gradient of 0, it means the line is flat. But if we have a line similar to that one, ladies and gentlemen, you can see it is not flat. It forms a certain angle. So that means there, the gradient, we can just say it is greater than 0. In short, it means the gradient, it is not, or this line, it is not flat, ladies and gentlemen. So again, you can have a line in that direction. We just know that this line, it is sloping, it is forming a certain angle. So it is sloping, it is not flat, the gradient, it is not 0. So it's more like it's either you have gradient which is 0, or you have gradient which is sloping in the negative direction. You've got gradient which is sloping in the positive direction. All of this can be calculated using that formula of change in y over change in x. Okay, so now I want you guys to notice which gradient is positive and which it is negative. Grace, we said this is a Cartesian plane. So a line, let's say that starts in the first and goes to the third quadrant, it has a positive gradient. But the one with a negative gradient, that is the one from the second quadrant going to the fourth quadrant. What am I saying there, guys? I'm saying this line, that straight line, it could be a line from point A to point B. Because it passes through the first quadrant and the third quadrant, the gradient, when you calculate it, ladies and gentlemen, it has to be a positive gradient. So why am I saying this? It's just so that if you find yourself in a situation where you need to calculate the gradient, expect a positive answer. But if you have a line similar to that, or you are calculating for the gradient of that straight line, for example, expect a negative gradient. Once you perform some calculations and you find a positive gradient for that line, just know that your new home is in the mountain, because we are going to give you a very big 0 for the calculation of that gradient, which will lead you to wrong directions, because you might need to continue with your calculations using that gradient. Ladies and gentlemen, before I move to the next part of my lesson for today, was everything clear, guys? Is there someone who's got a question, or did you all understand? YOLO, it's unfortunate we had to mute you because your mic was not muted. So I'm just going to unmute it so that you can participate. But remember, make sure to keep it muted, YOLO. Guys, was everything clear before I continue, or is there someone who's got a question? Grace, not Tolo, just mine to me. Shreya says he's there. Bonolo, Vuvu, Lebuhang, there, Mr. Lozuko, Elo.
Mr.
Oluyo. Was that a confirmation to say all was clear for now? I suppose the message is still delivering, so I'll just wait for a few seconds to get a response. Shreyas, I know your network is powerful there. Did you say all is clear for now?
Yes, sir.
Grace, can you confirm on your side? Hey guys. Okay, Grace, I thought you were watching Skim Sam there. Thank God you're still Bonolo.
I'm not watching.
Are we doing good? That side is all clear there.
Yes,
Okay, 100%. So remember, guys, this is not the first time I'm doing this lesson. Again, this is not my last time doing this lesson. Just make sure that in case if you missed my previous lesson, you catch it up. This is just it's more like a revision of what we've done. And again, just make sure that in case if you'd like for us to still redo the lesson, depending on what your package allows you, you can just request for this lesson again. Okay, so in addition to number 1, 2, 3, we've got what we call inclination of a line. So in other words, a vuvu is angle of inclination. So it doesn't really matter in terms of how you call it, but let's say a inclination of a line. I'll just explain shortly why I'm saying inclination of a line. So I've talked about those three. So now this is what I'm adding, ladies and gentlemen. Okay, so remember, let's first try to understand what we mean by inclination of a line. Listen very carefully. Angle formed with the horizontal in an anti-clockwise direction. Full stop, ladies and gentlemen. What is inclination of a line? This is an angle formed with the. So can you see? We're talking about an angle formed with the horizontal. What is the horizontal? Ladies and gentlemen, the horizontal is just a straight horizontal line in an anti-clockwise. Okay, so that means we know very well that we've got a clockwise direction. This is the direction in which a clock moves. So we know that it is moving in that direction. So an opposite of a clockwise would be an anti-clockwise. So in my definition of inclination of a line, I'm talking about three things, being the angle, the horizontal, and this angle being formed in an anti-clockwise direction. Let me represent these on a Cartesian plane so that it makes perfect. What is a Cartesian? Remember, guys, always, a Cartesian plane, it is made of these two lines. When you get to varsity, that's when they will introduce line number 3 called line number Z. No, not line number Z, but line letter Z. So for high school, it's just X and Y. So the horizontal between these two lines, which one is the horizontal? Obviously, this line of the x-axis is the horizontal line. Remember, I said when we define that, we talk about an angle, a horizontal, and again an anti-clockwise. So already I've got that line, which is that horizontal line. And then now the angle being formed. Remember, there must be obviously a line having 2 points. Let's say point Abraham there and point Byron there. So when we talk about the angle formed, which angle exactly are we talking about? So we talk about an angle which is formed with the horizontal in an anti-clockwise direction. So that means this is the angle that we're talking about. Okay, another Cartesian plane. Let me say let me draw something similar to that. This is the x-axis, a y-axis, and then there you can either have a function which is the graph of g. But remember, the angle of inclination, we talk about the angle formed with the horizontal in an anti-clockwise direction. Again, we can still have that line, ladies and gentlemen. Let's say these are the 2 points over there. So the direction that we're talking about is an anti-clockwise direction, and we refer to the angle formed to the horizontal. So that means this is the angle from the horizontal in an anti-clockwise direction up to where it touches that line. This is what we call the angle of inclination. So maybe for the last time, let me draw a line similar to that. So that means the angle of inclination, it is just a line starting from the horizontal to there. So it doesn't really matter that much if you draw that anti-clockwise line from that. What matters the most is that it starts from the horizontal and it ends to whatever the line. Then the angle formed is what we call the angle of inclination. So I hope you guys are now aware of what we are talking about when we talk about an angle of inclination. So remember, guys, everything that I'm telling you now is just a story that you need to be aware of. Don't worry about trying to grab everything at once or at the same time. You just need to be aware of everything that I'm talking about. You will have a better understanding when I solve exam type of question papers. I think as soon as I'm done with this presentation, I'll just pull one previous question paper that we can go through and discuss the questions, do an interpretation of whatever the diagram that we'll be having, and also go through the questions. Okay, so let me continue with the business of the day. Ladies and gentlemen, I want you to be aware of something. Let's try to check. Let's say we've got that being a Cartesian plane, y and x axis over there. And then let's say we've got a line similar to that. Let's say it is actually 2 points over there. So can you see here we've got a line, and this line, it is not flat, which means the gradient or g cannot, sorry, it is not 0 there. And again, because this line is radiating from the first quadrant to third, it's an indication that the gradient, it is actually positive. If it was that line, we're going to have a negative gradient. So the angle that we're talking about, ladies and gentlemen, it is this angle. What we call that angle, we call it the angle of inclination. Very, very much important, ladies and gentlemen, over there. So there is a relationship between this angle formed and again the gradient formula. So this angle, it tells us of the slope formed. It tells us more about the gradient formed. So that is why we have a formula that can help us to determine the angle of inclination. So in addition to 1, 2, 3 formulas that I've spoken about, this is the formula for that one of angle of inclination. So the formula says the gradient, it is actually equals to a tan angle of inclination. This is the formula, ladies and gentlemen. So let me try to extend this formula so that it makes perfect sense. Remember, the gradient formula, it is just change in y over change in x. And you'll remember very well that when we talk about tan, the ratio for tan, we do know very well that it is actually the vertical line over the horizontal line. So also on the gradient formula, it is the vertical line over the horizontal line. So also for tan angle, just remember that a ratio for tan. For some of you guys that we haven't done trigonometry, let me not go deep into that so that we are all on the same page, but it will make a perfect sense at a later stage. So that means this is actually equals to tan of the angle formed. Remember guys, it doesn't necessarily mean that this angle will always be angle theta. It could be alpha, it could be beta, it could be anything else. Ladies, it could be whatever. It can be referred to whatever. So normally they like using a theta, alpha, or beta, ladies and gentlemen. So this is the formula to help you calculate the angle of inclination. So it's more like a question would say, what is that angle of inclination while you're given these 2 points? So it's just a matter of you using the 2 points to calculate the gradient. Once you have the gradient, you can say, some of you guys say arctan of whatever the gradient. Some of you say second function of the gradient, then it gives you that angle. So we know that, okay, this mountain, it is actually at an angle, let's say, of 45 degrees. Then you know when you go for hiking that, hey, it's going to be difficult for me to climb this mountain, which is at such a huge angle. But now, if it is just a mountain, let's say it is going like that, then you know very well that no, this one, it is actually not that steep. So the angle, remember, the angle starts from there, which is 0. So as it goes in that direction, it goes deeper. It gets more. Remember, this is 90 degrees. So that means something flat, it should be less than 45, because 45, it's right in the middle of 0 and 45. So any mountain which forms an angle, let's say, less than that, we can assume for it not to be too steep. But for those mountains, ladies and gentlemen, like Table Mountain, imagine having to climb this. I'm telling you, you'll be rolling by the time when you get to that point over there. But hey, guys, don't go on hiking and say I can climb what is it, a mountain that is at an angle of whatever less than 40. Hey, you will sweat. I'm telling you guys, don't take that risk. Okay, what else do I want to talk about, ladies and gentlemen? I think I've spoken about almost everything that I wanted to talk about. But the last thing that I want to mention is this. Remember, guys, let's say the formula there, it is gradient being equals to tan of angle over there. So remember, we've got a positive gradient and negative gradient. So you could be having a Cartesian plane there, and again having, let's say, that line. So remember, in this case, it means we're having a positive gradient. So there you are going to have that angle of inclination over there. So that means we are actually going to be having an acute angle. What is an acute angle? An acute angle is an angle formed in the first quadrant. So it's just an angle which is less than 90 degrees. Or between 0 degrees and less than 90 degrees. You remember we said the first quadrant forms acute angles, second quadrant obtuse, third reflex, and then there reflex. What is it? Revolution. Yes, acute, obtuse, reflex, revolution. So that means when we have a positive gradient, we just know that a tan of the angle of inclination is equals to the gradient. Then it ends there. But when you have a negative gradient, it's a different story, ladies and gentlemen. It's a different story there. So that means you are having an obtuse angle. So let's say you are having an obtuse angle. What is an obtuse angle, ladies and gentlemen? Obviously, an obtuse angle is that angle which is, let's see, from 0, 1, 2, 3, 4, 5, 6, 7, 45, whatever, 89, 90 degrees. Then it goes beyond 90 degrees. That's what we call an obtuse angle. So obtuse angles are formed in the second quadrant. So in that case, ladies and gentlemen, when you use this formula to say tan, what is it? Tan that angle of inclination being equals to G. You might have a negative value over there. So that negative value as the angle that you're going to get, it actually gives you the angle at the back. So it actually gives you that angle. So for you to get this angle, you might need to say 180 degrees, then you subtract that angle, then it is going to give you this angle formed. Maybe let me use angle alpha there, and say it is going to give you angle theta. So what I'm saying, ladies and gentlemen, is that when you have a line in that direction and you use this formula, you might get a negative gradient. And of course, we said for these lines we have a negative gradient. So, but the angle of inclination, it is not that one. So the negative angle or the negative gradient that you get, it actually gives you that angle over there. But the question wants you to give angle of inclination, which is that one. So for you to get that one, you will say 180 minus that negative angle that you got, it is going to give you this. But when it's for a positive line, it is just straightforward. Remember, guys, everything that I'm saying now, it is just for you to be aware of. It doesn't necessarily mean that everything has to stick to your head. You just need to be aware of all of this. This lesson is going to be made available online. You can still watch it over and over and over and over again. Then, when we solve for exam type of question papers, I'll be referring to everything that I've spoken about, and that's when everything it's going to make a perfect sense. Shreyas, it may take you, let's say, 3 weeks for you guys at school to complete this chapter, but in my lessons, I try by all means to summarize everything in one lesson so that it's easy to access all the information in just one lesson. Then you know that when you practice for your exam or for your test or whatever, you just watch this 1 hour 30 minutes lesson. Then you know you've got a summary of all that you need to be aware of as far as analytical geometry is concerned. So let's, guys, for those of you who call it analytical geometry, I'm referring to the same thing when I say analytical geometry. It's one and the same thing. So I just have to make sure that I combine all the information in a form of a summary and present all in just one lesson. So don't worry if you feel like I've lost you somewhere. Just be aware that you will still have an opportunity to catch up, and when you develop some questions based on whatever that I'm teaching now, on my next lesson or whenever we do a private lesson, we can still start from here where I address all the questions that we'll be talking about. Okay, so now, in addition to inclination of a line, ladies and gentlemen, you need to be aware of what we call equation of a straight line. Let's see, equation of straight line. Okay, so also an equation of a straight line, it has got a general formula being y is equals to mx plus c. You remember when I was doing a lesson for functions, I did explain to say where this formula comes from. So that's a lesson for another day, but for now I'll just leave it there. That lesson is live, it's posted. Just in case if you need a link, just let me know, I will share it with you. So, ladies and gentlemen, obviously to determine an equation of a straight line, you need two things again. What is it? So it's more like this is just a game of two things, ladies and gentlemen. Analytical geometry is a game of two things. Whatever that they might want you to determine or find, ask yourself, do I have two things? For distance, do I have 2 points? Midpoint, do I have 2 points? Gradient, do I have 2 points? Angle of inclination, do I have 2? Remember, guys, angle, it's a value which is measured in degrees. It could be 40, it could be whatever number, but an angle, it is measured in degrees, ladies and gentlemen. So just be careful of that. But when you calculate distance, it's just a length. You can say whatever units. The midpoint, you can see, is the middle point, and a point, it is represented by the coordinates of x and y. The gradient, it is just a unitless value. So you can't say the gradient is, for example, 2 meters. It is no longer gradient, but it is a length. So let's say no unit there. What is it? Angle of inclination, we know that one, it is actually an angle. It could be 30 degrees. So it is measured in degrees. So here we are now on an equation of a straight line. So again, when you determine an equation of a straight line, you need two things. What are those? You must be given 2 points again. But examiner might try to be smart and not give you 2 points and say, this line has got, or that mountain has got a gradient of this much, and they give you 1 point. Still, it is two things that you need. So this is a game of two things. You just need to be aware of what are those things. Is it 2 points that I need? Or is it a point and whatever? What could be that whatever? So that means if they give you a 1 point, ladies and gentlemen, they must also give you the gradient. So remember, on a straight line formula, we have the y being equals to m. M represents the gradient. What is the gradient? The gradient is that delta y over delta x. In short, it is actually, what is it? Y2 minus y1 over x2 minus x1. So this is actually the gradient on that formula. And then this is just an x over there plus c. So this c, they can either use letter c or they can either use letter q or whatever. It's more like whoever who contributed towards the formation of that formula, their name was, maybe it was Connie. So they just decided to say, no, we name it after my name. We call it Connie. What is it, Connie? Q, Quentin. Maybe Q. Okay, no, it's fine. In my case, I would call it a D. So that means it doesn't matter, ladies and gentlemen, whichever word or whichever letter that they use, just know it's a constant. So it suits to be C, so that we can just say it's a, what is a constant? Is just a number. Bantwana bankulunkulu. A constant, it is just a number. What is a number? A number is just, guys, a number, it could be 0, 1, 2, 3, whatever. This sign, it could be a positive or a negative. It all depends on multiple factors, of which when I do a lesson for straight lines, I will explain all of those. Okay, so now the last thing that I want you guys to be aware of. Remember, I've spoken about all of those. The last thing that I want you guys to be aware of. Once you know this, then you are done with analytical geometry. What you should be struggling with is how to answer the questions. I'm telling you guys, trias, it might take you guys 2 weeks at school to complete all of this, but just be aware that it doesn't necessarily mean that all the chapters should take that long to complete. You can still take 1 hour to study the whole chapter and then you are done. So that's why I'm saying it's best for me to have a summarized of everything and then summarize it in one lesson. Remember, guys, in case if you are in my grade 10, 11 or 12 classroom, that's where I'll be sharing all my notes. So what I'm presenting now is based on the notes that I've done. So I'll share the notes for all the chapters that I've already done the notes so that you guys can access these notes. I'm also going to link them with the lessons that I've done. For example, now I'm doing this lesson for analytical geometry. So I'm going to just have the notes in the end or at the top, have a link whereby you study the notes. In case if there's something that you don't understand on the notes, you click on the link, it takes you to the lesson, then you can watch from the beginning until the end of the lesson. In that way, you will be rich in knowledge, ladies and gentlemen. Then as you attend more of my lessons, that's where I'm going to be teaching you guys on how to approach exam type of questions. Okay, this is what I want to talk about. For lines which are parallel, so that means for parallel lines, this is how we represent parallel lines. So for parallel lines, ladies and gentlemen, let's say the gradient of the first line will be equals to the gradient of the second line. Again, so it's either we have lines which are parallel or lines which are perpendicular in analytical geometry. What are parallel lines? It's just lines which are parallel, ladies and gentlemen. When we say you and I are in the same group, you are just representing parallel lines. So these are the lines which are running parallel to each other. They will never cross. They will never do whatever, ladies and gentlemen. So parallel lines never cross, in short. But lines which are never parallel, somehow they are going to cross each other. So in this case, we're talking about lines which are either parallel to each other or otherwise they are perpendicular to each other. Perpendicular lines form an angle of 90 degrees. So can you see, when you have lines which are perpendicular to each other, this is the 90-degree angle that is being formed over there. So we say when you have, or for perpendicular lines, when you multiply gradient of the first line being that one times the gradient of that other line, the answer that you get, it is always -1. I'll just give a very quick example over there, ladies. So this is a Cartesian plane. Guys, we draw everything on a Cartesian plane. So never confuse the lines on a Cartesian plane. So that means on a Cartesian plane, you will always have what is it? A vertical line and a horizontal line. Then we draw two lines to explain. So there is a line, there is another line. So let's say this is AB, this is CD, or otherwise it could be a function being the graph of G, being the graph of H. So can you see? These lines, they will never touch, ladies and gentlemen. I'm telling you, if this line is heading to Algeria, it will just go straight to Algeria. Also this one, they will never cross each other, ladies and gentlemen. So that means the gradient of this line and that line is the same, which means if you had to climb this mountain, you were going to be the tired in the same way if you had to climb this mountain, even though this one is somewhere there and this one is somewhere in Limpopo, but they just have the same grade. The moment we have another line, let's say maybe it is crossing like that. So can you see? They cross it. Oh, ladies and gentlemen, perpendicular lines. Ke sefapano. I'm not sure if you guys know this song, Sefapa. No. The tune is wrong. Forget about that song. You get it. Where's LB? LB was going to tell you guys to say, you get it. If you don't get it, you forget about it. Okay, so this is me saying forget about the song. But what I'm saying is that when we talk about perpendicular lines, they form what we call sefapan, ladies and this is sefapan. It's just a cross. It's just a polars. It's just an addition sign. This is what we call a perpendicular. The angle formed there, it is 90 degrees. So to make it easy to explain, we just remove that. So can you see? It takes us back to that. So that means parallel lines, they run parallel, they'll never cross. Perpendicular lines is just lines crossing at 90-degree angle, at 90-degree angle, at 90 doesn't matter where you draw that angle, as long as it is there, we notice it is a right angled. If the triangle is formed, it is going to be a right angled triangle because of that 90-degree over. Ladies and gentlemen, is there someone who's got a question based on my today's lesson, guys? Or were you guys following? I'll just be looking for a question in the meantime, something that we can just quickly go through to check. Guys, are you still there, or am I preaching alone here?
No, sir.
Someone confirmed to say we're still together. Is there someone again on the lesson to just confirm for me? Because, you know, guys, as I'm speaking, I'm just speaking, hoping I've got learners attending, because I'm not able to see unless if I check who has attended.
I'm also present.
Let me see. I think I heard Mr. Luzuko's voice. Okay, is the hello.
Together.
Okay, no, it seems like we are together, guys. Guys, I've got a question that I would like us to just quickly browse through that question. Let me do this quickly. I might need to draw this in case if you guys say it is blurry there. Let me try to do this. Guys, can you tell me if you are able to see on my screen there, or is it blurry on your side? Let me maybe do this, because you know there's load shedding on my side, so I've got.
It's blurry.
It's okay. Let me try something. Let me try to see. I think now it's worse. Is it not worse now?
It's worse.
Let me try this, and then no. Okay, how is it now?
So we can only see the diagram, but we can't read the questions.
Okay. Let me try do this. Then I'll try to zoom in and see if you can see the text. Can you see now? Maybe. How is it?
It's much better, sir. Yes, better.
Yes, now we can see, sir.
Okay, 100%. So, this is one of exam question papers. What I'll try, maybe let me try do this. Is it better now? Can you clearly see now?
Yes, sir, it's perfect.
Yes, sir.
Perfect. Okay, so let me do this. So what I actually want us to do, guys, is just to quickly try to go through the given statement, and then from there browse through the diagram, and then try to check the questions. We won't be answering anything. It's just for us to browse through to check if all that I was preaching about can actually be applied to this thing. So let's see. Question number 3 over there. It says A, remember letter A represents a point and these are the coordinates. So they say A having -2 and -5, B, C, and D are the vertices of a quadrilateral. So the word vertices, it seems to the corners of a quadrilateral. Quadrilateral, I think, is just a shape which has 4 sides. So of quadrilateral A, B, C, D. So let's see. Okay, there is A, there is B, there is C, there is D. So can you see? 1 side, 2 side, 3 side, 4 sides. That's a quadrilateral. Very, very much important, ladies and gentlemen, over there. Are the vertices of a quadrilateral such that diagonal AC, where's AC? There is AC is perpendicular to diagonal BD at T. Okay, I'm noticing something. So they are saying diagonal AC is perpendicular to diagonal BD. So can you see, guys? My Bible has got Moses there, the perpendicular. I'm sure you remember me talking about what is it, guys? You remember me talking about perpendicular lines. Can you see now? My Bible is up to date, ladies and gentlemen. Let's see. The equation of BTD. Where are those? What are they talking about? Where's oh, there's B. Where's T? Oh, there's T. D. Oh, there's no. It seems like everything they are talking about is there. Is given by 2y plus x is equals to 18. Hey, there, examiner is trying to be tricky. I'll explain to you guys shortly. So, and they say, and AB, where's AB? oh, there's A. Okay, now I see there's A, there is B. They are saying is equals to 15 units. So they are saying, units. That means they're talking about a length or distance. Okay, now it makes sense. Let's try to now check the questions. Okay, before I even go deeper, I'll just explain to you this. When I said examiners trying to be tricky there, we just know the formula of a straight line, or the formula, yes, the formula of a straight line being in this format of y is equals to mx plus c. But can you see there, examiner is trying to be tricky by giving you in that format. So that means if you attend my lessons, you will notice that you will need to rewrite that in the correct format so that you are able to therefore answer the following. So that means you just need to transpose and divide by that. So that means you end up having y is actually equals to, let's see, when you transpose it's negative x. So this is me trying to just quickly give you how the standard equation will look like. Don't worry that much. We'll still redo this question. So from tomorrow, being Tuesday, Wednesday, and whatever, we'll just be solving exam type of questions. So just make sure not to miss that lesson. So can you see? That means the gradient for this line that they're talking about is actually negative half. Let's see that line. Where's that line? B, T, N. So can you see? This line, of course, it has to be a negative gradient because it is radiating from the second and the fourth quadrant. You remember me saying line from second to fourth, it has what is it, negative gradients. This positive 18, it is that point over there. When we do a lesson for functions, everything is going to make a perfect sense, guys. So before I go to the questions, guys, did this make sense to everyone? Are you guys not lost there? Even though you might not be 100%, but are we still together there?
Yes, sir. I understand.
So understand.
So Some of you guys, you do understand, but you are scared to say understand because you think I'll ask you a question. Today, I'm not asking anyone question, guys. I'm just going to be I'm going to ask myself a question and still answer the question. So even if you say you are lost, I won't ask you a question. I will just try to explain differently. Okay, I think now I need to talk about this thing, guys. This is serious. Before I go deep, let me talk about this thing, guys. I want to tell you guys to say, as time goes on, okay, let me say, at first, myself, when I was in grade 10, I thought I'm a slow learner, guys. I thought I'm a slow learner. But after some time, I realized that we have two things. It's either we have what is it? A slow learner, yes, and again we might have a slow what is it? Tutor. Let me say a slow tutor. So if you don't understand whatever that I'm talking about, guys, it is not because you are a slow learner. It could be that I'm a bad tutor. So never ever make an assumption that the reason why you are not understanding, it could be your tutor, your teacher, your mentor, whoever. Never make an assumption that is because you are a slow learner. Ask yourself this question: are they also good teachers? Are they also good mentors? So just make sure, ladies and gentlemen, that whatever that I'm saying and you don't understand, and everyone says they understand, just make an assumption that it's either you missed some of my lessons. It's either you are less informed, or otherwise it's either I'm not a good teacher. But what makes me to say I'm a good teacher is because some of you guys, you do understand my lessons, and you understand because you've been attending my previous lessons. So that means it should serve as an encouragement to you that if you continue to attend more of my lessons, you will also be on the same page as I do. When I do other chapters. So, guys, no one is a slow learner. It could be that we are just not good in teaching you guys. But once you find the right teacher, you will notice that you can understand. But why would you still fail if you understand? It's because you are not yet exposed to how exam questions are being asked. Let me try to do something over there and say 2 plus 2, it is equals to 4. But in exam, they are going to ask you in a tricky way, even though they will say, whatever that we asked you, the answer it is 4. Just show us how the answer it is 4. So that is how tricky examiner can be. So regardless of you knowing everything that I've spoken about when I was doing this introduction for analytical geometry, you can know everything, but if you don't know how questions are asked, you will still fail. That is why I call this channel Solving Exam Papers. I'm mostly interested in solving exam question papers. So in my case, when I was studying, I just read textbook chapter from the start until the end 3 times a day. Then I'm done. All that I do is just to solve exam question papers. You learn more in solving exam question papers than reading a textbook, because each year they ask the same thing but differently. So as you do more question papers, you end up realizing that in 2015 they asked these questions this way, 2016 this way, 17 this way, but you end up realizing they are actually asking you the same thing. Have you seen someone asking you how old are you, but they are not saying how old are you, but you can feel it, you can smell it, to say, hey, this one, they want to know how old are. So it's just the the manner in which questions are asked, but the answer to the question is, ladies and gentlemen, can you still see there? Is it clear there?
So it's a bit blurry.
It's a bit blurry, ne? How about now? Is it still blurry?
That's fine. So at least now we can read.
Okay. So let's see. The first question there, it says determine the gradient of line AC. Can you see? And this question, okay, no, it's fine. Let's not worry that much about the mark. So it's 223, 242. Okay. So the Vovos, they are saying determine the gradient of a line AC. Ask yourself this question. Do I have two things for me to determine the gradient? Examiner, why are you saying I must determine the gradient? Okay, it's fine. I don't even want to know why you're saying must determine the gradient. I know you want me to end for those 2 marks. Okay, which gradient for line A? Where's line AC? Let me see. There is the line of A. There is C. Okay, there's point A there. Sure. Can you see? Seems like I don't have a the coordinates of C, which means you must try and find something again in order to use to determine that gradient of S. But I think I did say if you have a straight line like that and you still have another straight line like that, they form a 90-degree angle. And we said the gradient of this line, when you let's say the gradient 1 times gradient 2 will be equals to -1. This line, the gradient of that line times that line will give you -1. So can you see, from that formula, you can find the gradient of that line. Then you substitute it there. Then you say the gradient of this line, which is gradient 2, it is going to be equals to -1 divided by the gradient of that line so that it cancels and you remain with it. So can you see, guys, you need to be umele uzitsonge, guys, umele uzitsonge lezi zinto lezo. The Vuvus, you must be clever there. Can you see? They won't straight away just give you 2 points and say what is but even though when I was presenting the notes, it sounded like they will just give you A, but they won't. Trust me on that one. They will always be tricky, which is what I'm going to be teaching you guys as we go on. But everything is based on that presentation can you see? I've answered this question based on what I told you guys. That is why I will never help a learner who says, I'm writing, can you help me with this question? I won't do it if I don't know if they know what they're supposed to know. So I'm firstly going to take you through that same lesson or give you a link to watch that same lesson. Once you've watched it, then I know everything that I'll be talking about will be in the same words. Okay, determine the equation of AC in the, okay, now if you want me, Mr. Examiner, to determine an equation, do I have 2 things? Did you give me 2 things? If they did not give you, then you must find them. So do I have them or can I find them? Remember, guys, remember the line that they're talking about is that line. So if you remember very well, I said to determine an equation, it's either you've got 2 coordinates or otherwise they give you the gradient and 1 point. So can you see? There we calculated the gradient of that line and we have 1 point over there, which means we can easily determine an equation of line AC. Easy there, the Vovos. Let's see. If the equation of AC is equal, hey, that means when you determine that equation, it must actually be that one because they're saying if the equation of AC is equals to that, calculate the coordinates of T. Where is T? Oh, can you see? T is actually a midpoint of that, and again midpoint of these 2 points. So it's either you can equate a equation of that line and that line, then solve for x and use the x value to substitute in one of these equations. Remember, guys, these are some of the tricks that you develop when you attend my lessons on functions. Remember, I'll still be redoing those lessons. In some instances, I'll just replay the recorded lesson, and then in the end, I'll be taking some questions. It will just depend. Let's see. Can you see if this is a kite with AB being equals to that? Determine the coordinates of that. I'll still take you through that. They calculate the length of BT. So can you see, if you want me to calculate the length, let's see, where's B? There's B, there's T. If you want me to calculate the length, do I have the 2 points? If I don't have the 2 points, it means I must calculate the second. So can you see, there's a question that says calculate the coordinates of T. So if now they're talking about BT, it means you need the coordinates of T. So that means you must find T first in order to answer the question. So the main question is, do I have two things? If they say, how are you? In the question, ask, do I have two things? It doesn't matter whichever question examiner asks you. If they say, did you have breakfast? Just say, do I have two things? Guys, you get it. If you don't get it, you forget about it. Okay. The last one. Write down the length of the radius of the circle passing through that. So can you see, this is something that I haven't taken you through. Why? Because this is not a question which is common to all grades. You can only find it, let's say, either in grade 11 and 12, but it's not there in grade 10. So that means as we go deeper, especially on lessons which are specifically for grade 11, that's when we're going to include that information. Ladies and gentlemen, I hope you guys had a fantastic lesson, and this brings us to the end of our lesson for today. Ladies and gentlemen, please do allow me to say quickly, it is very much important that I say it is very, very much important, good people, because what I'm about to say, it is massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Please do make sure that by the end of each and every lesson that I conduct, the vuvos, you learn something new. I hope you did learn something new out of today's lesson. So before I close, did you all understand, ladies and gentlemen? Is there someone who's got a question or says Grace? Cox are the Cox. Kwamba, hello. You haven't said, and can you just cough so that we know you are attending? Yolo, how are you doing there? Mr. Lozuk, are we okay that side?
We are
Bonolo?
fine. We are fine this side. Even though
100%.
I would like to request that I have this lesson from the beginning because I started late.
Oh, you started, okay. No, then it's fine. In your case, you'll be covered, Mr. Lozuk. So it's being recorded, and then we can still redo it on our private lesson. So worry not, Mr. Lozuk. The vuvus kuhamba njani lapho? Shreyas,
So I understand. Thank you.
do
Understand.
me. Bonolo, hello, Yolo,
So I understand.
Cox are the
Some.
Cox, Grace. Okay, guys, I'll just end the lesson with an assumption that we are all on the same page. I understand some of you guys, you are far, so the message is still on the way. I'm sure it's now in Joburg heading to
So far, so
Kwamhlanga.
good. So.
Can you see? My message just got to KZN. Okay, Koksa, thanks for that response. I'm just not sure. I think Elo is watching Generations, but it's fine. Guys, at 2030, no, not not in 2030, at 8:30 in 3 minutes time, there'll be a lesson for what is it? I think it might be delayed by 5 to 10 minutes. I'll just send a notification for accounting. So just in case if you're doing accounting, make sure to join for that lesson. Okay, cheers everyone.
Cheers.
All right, sir.